Hi, my name is Sarah Gray, and I'm a Security Specialist Solutions Architect at AWS. Today, I will be presenting our third topic in our Build and Improve Cloud series as part of our Well-Architected series on security best practices. As a security specialist, I'm often asked by customers, how do I build securely on cloud, and what security best practices do you recommend? Today, I'll be covering those topics, along with showing you some labs so that you can work alongside with me in understanding how you can deliver securely on AWS. So to get started, what I always like to tell customers is some security design principles that they can work with when they're thinking about how they're going to build and architect on AWS. As we work through the content today, I would like all of you at home or in the office or wherever you're watching today to think about these as we move through the content. The first one is about implementing a strong identity foundation. This is about implementing the least privilege principle, making sure that those users that you have that you're giving access to your environment are the only ones that are authorized to do so, that you have really good segregation of duties, and that you've got a centralized and appropriately restricted access to changing those users. Enable traceability. This topic is around not just monitoring and logging your users, but also having some visibility across your AWS environment of what changes are happening, being able to know what is happening when, and having good visibility of that, and making sure that you have the mechanisms turned on for that to happen. Apply security at all layers. This one's really my favorite in AWS because it is quite simple to implement. This is about making sure that you apply a security defense in depth model to your environment, making sure that you have appropriate restrictions on your virtual private cloud, that you're appropriately segregating it in terms of your subnets, and making sure that you have good firewall rules and that, again, appropriate access to services. The next one is also my favorite, and it's around automating security best practices. We have a number of tools and mechanisms that can enable customers to be able to automate threat detection and automate the response process. We'll be covering that today. Protect data in transit and at rest. This is around having appropriate mechanisms in place to protect the confidentiality, integrity, and availability of your data. Keep people away from data. This is around implementing security as code and applying mechanisms to have users not actually access production code or access their environment as much as possible, or not using making direct access. And then prepare for security events. This is around having a known process for how you are going to respond to an event when you detect them, knowing the prioritization of those events, the process, and who you'll contact when an event arises, and what you'll actually do to remediate it. And then as part of our well-architected framework in our security pillar, we have a number of security best practice areas. These are identity and access management, detective controls, infrastructure protection, data protection, and incident response. Each of these areas are important for supporting against not only financial and data loss, but also supporting compliance with regulatory obligations. We will be covering these areas today. Also today, we'll be looking at preventative approaches, detective approaches, and corrective approaches. I'll now take you through how that applies to the different areas. Some of these areas actually have protective and detective mechanisms, and then we can then map these to the actual services and some of the controls that we have within AWS. Something that I really like to put this to illustrate this area a little bit more clearly is AWS organizations. A big part that I mentioned earlier around identity and access management is around making sure that you have centralized management of your environment and your users. AWS Organizations is an excellent tool for enabling that centralized management and governance of your AWS accounts. It also, with the use of service control policies, allows you to automate to some extent your infrastructure security. Now we're going to cross to a poll, and I would really like everyone at home and in the office or wherever you are to answer this one. I'd really like to know, in which are you the weakest or need the most improvement? Is it in identity, detective control, infrastructure security, data protection, or incident response? If you can select your answer, that would be wonderful. And we might cross to the poll results.
Oh, the room's muted? Okay. I posted the poll results. Feel free to begin whenever you're ready.
So we might cross now to our well-architected security labs that we will be doing today. They will be covering the protective, detective, and corrective areas that we explained earlier. We'll cross back to that poll later when we have a chance. It seems to be some sort of a technical difficulty, but it's all good. Today, when you're working along with me in these labs, I'll need each of you to have your own AWS account to build the labs. Please do not use a production account. You must also have a role with administrative privilege. I know we spoke about earlier about applying the least privilege principle, but today you will need administrative privileges to run the labs. Also, there is a lab that we will be using the command line interface. You will need to have this installed and configured to be able to do that lab. And at the end of the lab, I will remind you, but it is your responsibility to make sure that you delete everything and tear down the labs afterwards, as they might incur a cost if you leave them running. If by any chance today you don't have these set up, that's fine. I'm happy. I'll be taking you through all of these labs in depth on our well-architectedlabs.com site that we will provide a link to later. There will be an opportunity for you to go through these labs and more at your own leisure. So as I mentioned before, we will be breaking down the labs into 3 areas today. We'll be doing a Preventative Controls Lab, a Detective Controls Lab, and Corrective Controls Lab. Preventative Controls Lab. So the Preventative Controls Lab is actually available on the link that you can see on the screen now. What we will be doing is doing an automated deployment of a virtual private cloud, or VPC. I'm going to cross now to the lab content for you to follow along. So this is the lab that you will come to if you follow the link that I gave earlier. The lab will give you an introduction around what you want to do and the goals. So today's goals, we will be looking at the security features of a VPC, the VPC layered subnet architecture, and have a look at automated deployments. We'll actually be deploying this virtual private cloud using CloudFormation service, and it will be completely automated. Let's start the lab now. So you'll see this is a high-level architecture of what we're going to be developing today. In our AWS environment, we will be creating a virtual private cloud that will have 3 availability zones associated with them. You can pick what region you choose to do this in today, but today I will be demonstrating it in our Sydney region, as that's my region of origin. We'll also be developing a number of subnets in each of those availability zones. We'll have some public ones and a subnet for each of our load balancers that we could put in as well, with a NAT gateway attached. We'll also have a private subnet for each of our applications and private subnets reserved for our databases. So now we're going to be creating our virtual private cloud stack. To do this, you need to download the latest version of the YAML CloudFormation template that you can get from GitHub. I'm just going to download this now. Now we're going to go into our CloudFormation in the management console. I will let you know here, if you are doing a number of the labs as part of the Well-Architected Security series, you need to make sure that when you name the stack, that you name it exactly as it is in the instructions. So I'm just going to go to CloudFormation. I've used it before, so it's here on my recently visited services, but you can also access it by entering it in the search bar here. So now we're going to create the stack. As I've already downloaded the template file, I'm going to use upload a template file, and now I'm going to choose the file. So you need to enter in the stack name. I don't know about you guys at home or at the office or wherever you are, but I often forget to put the stack name in. Make sure that you pop it in at the top. The next is the general configuration. We're going to leave it as default for this lab today, but there is the opportunity that you could change these if you needed, especially considering that there's CIDR blocks there and you wouldn't want them to have any overlap with your environment. There's an opportunity here to place tags. Ideally, I would place tags, but for the purpose of today's lab, what I'm going to do is just leave that blank for today. And here is a summary of what everything's going to be built. And I'm just going to scroll to the bottom. And I need to acknowledge that an IAM role will be created as part of this stack being built. And now I'm going to hit Create Stack. And I'm just going to edit this again. I think it did not like my space at the end of my script. And we're in progress now. So this script will actually generate a lot of resources as part of it, and it's going to take some time to build. So I'm going to take you through the YAML script just so that you can see what we're going to be building. So the thing I really, really love about this lab is, although it's really simple and you're essentially just filling out a simple CloudFormation form, the power of this lab is actually the YAML script that you have associated with this lab. What you can do is actually review the code, and you could actually what you could actually do is edit this to meet your environment's requirements or what you're planning to build. So I'm just going to scroll to the top here. So as you can see, we've got the parameters, the CIDR blocks. You can, as I mentioned before, you could edit this as code because this is code to what it needs to be for you. You've also got in here the regions that you're going to be possibly using, some mappings for the regions. And then here is the beautiful part, the resources. Now, I showed you that diagram before around what we were going to build. Maybe that doesn't really fit in with what you were wanting to do for your environment. So what you could do is actually use this script as a template and edit it to meet your needs whilst being able to achieve security best practices. I'm just going to see how my CloudFormation script's going. So it's going there. As you can see, there is a lot being built at the moment. Whilst that's building, I will take you to the, we'll look at the architectural diagram and we can go through it again. So as you can see, what we have there is we're essentially building a defense in depth, but we're also applying the automated security principle that I explained earlier. The defense in depth means that we're essentially creating an environment by which we would be able to restrict the ins and outs and the public access associated with our environment, and also establishing how we would control the private access to our environment as well. The 3 availability zones, we're also ensuring that we're set up for our environment when we start to put instances in it, that we will be able to achieve high reliability, which is really important for the availability part of the CIA model. I'm just going to see how our CloudFormation stack's going now. And it should be complete. Yes. So we've now, just in a matter of minutes, built a full end-to-end virtual private cloud with multiple availability zones, multiple subnets. It's got public and private access for, and ready to go for us to build an application, employing all of the security, employing security best practices, ensuring that we've automated security using CloudFormation, doing security as code, as well as being able to edit the code to meet our policy requirements. So just to give you some visualization of what we're planning, what you could do with this virtual private cloud, is that you could eventually place in some auto-scaling groups to have multiple instances spread across the availability zones in your private area. You can also implement some load balancers to make sure that you have availability and it's spread across those scaling groups. And then we've also created some endpoints for our S3 buckets when we create them if we wanted to eventually. Now that we've got some preventative controls in place, the next step we're going to do is implement some detective controls. Again, we will be using CloudFormation to do the deployment of detective controls. The lab that we're going to do will use CloudFormation to deploy Amazon Guard Duty, which is our managed threat detection service. I really love this service. When customers turn them on, they're always surprised by the events that come up. It uses machine learning information that we've gotten from partners to be able to detect potentially malicious and anomalous activity. We're also going to be building some guardrails using AWS config. So this will allow us to have some compliance checks around how we want our environment to operate. And we're also going to use CloudTrail, which is our logging service, which provides a history of all of the events that will be occurring in your AWS environment. And it also provides a mechanism for storage. So going into the lab again. This is the second lab that we will be going to today, the automated deployment of detective controls. As I said, the goal of this lab is to implement detective controls and automate security best practices. I'm going to start the lab. Again, we are going to be using CloudFormation as I explained earlier. And there's some descriptions around Amazon Guard Duty, CloudFormation and config, which I've already explained earlier. Again, we're going to have to download the YAML script for this deployment, and that's available here. It's also, again, available in our GitHub repository. So I'm just going to download it now. And we're going to go back to CloudFormation, and we're going to build this stack again. Or build this stack for the first time, I should say. I'm thinking about the previous stack. Let's hope we have more luck with this one than we have with the last one. So again, we've already downloaded the template. So we're going to upload the template from file. And make sure you select the right one. It's the one with guard duty. And we're going to enter in a stack name. So I'm going to call this Detective Controls. Now this is a fun one. When you're reading through the instructions, it will say if you've got CloudTrail already enabled to select no, if you're using config already to select no, and guard duty already to select no. I actually have, for the purpose of a later lag, guard duty already turned on. So I'm actually going to leave them all as yes, except for guard duty. There is the option here to do an S3 bucket policy illicit deny. I would normally recommend that you would use, definitely do that. It creates additional controls on your buckets, but for the purpose of today's lab, we're not going to do that. For our CloudTrail, don't copy the bucket name that I'm going to be using this if you're following along. These bucket names have to be unique, so I'm going to enter in a bucket name now. And I want to make sure that I have, for my config bucket, the same naming convention. Now, some of these other fields you see are able to be added. So it's around log retention time. You might want to do that according to whatever regulatory or organizational policy that you have. There's also the option to encrypt. Normally, I would definitely say to encrypt, but for the purpose of today, I'm going to leave that as a no. There's also an email down at the bottom that you can enter to receive notifications from guard duty. I'm just going to leave it as a default as it is today and hit next. Again, we're able to use tags for this. I would definitely recommend the use of tags, but for today, we're not going to do that. Again, this is a summary of everything that we're going to build. And again, I'm going to be creating an IAM role as part of this, and I need to acknowledge that. And I'm going to hit Create Stack. This one has a little less that we're going to be deploying as part of this one. So it will operate quite quickly, it will build quite quickly. We will progress to the next lab as part of this whilst this is building in the background. So the third lab is around enabling Security Hub. This is a really great service because what it allows you to do is actually aggregate into a central location all of your notifications and events from a lot of your security services like Guard Duty, Macy, and Inspector all into one spot. It also benchmarks compliance against the Center for Internet Security benchmarks for best practice configurations for AWS. So you have visibility of not only how all the notifications that are coming into one area and having a centralized management, which is really great if you're in a security operations center or a SOC, but also it's really great to have an understanding in a single spot how you're meeting, how your environment is placed against highly regarded best practices. So I'm just going to go back into the lab instructions. And it's just enabling Security Hub. I'm not going to go into the instructions in too much depth here because I'm actually going to demonstrate it to you, but there is full instructions around how you can deploy Security Hub in your environment quite easily in the instructions. But I'm just going to head to Security Hub now. Okay, so if you're using Security Hub for the first time and you don't have it turned on, you'll come to a screen like this in the management console, and we'll just go to Security Hub. And it will come up with a welcome screen. It will advise you of some permissions that you'll need to give in order to use it. And then there's a button at the bottom here to enable AWS Security Hub. And I'm going to enable that. So as you can see, it comes to a really simplified dashboard around some key insights around findings that you have across your AWS environment, as well as how the environment meets various compliance standards. At the moment, the tool, as we've just turned it on, is currently analyzing our environment, so it's going to take some time for some input to come in there. I'm going to go back to our CloudFormation and see how our detective controls are going. I'm just checking what happened here with the fail on this being built. Just a second. Oh, and it's, as I explained, the bucket already exists. So we'll go back and do it again. The joys of a live demo. So we're just going to create that stack again. I'm going to make this super unique so we don't have this failure again. This is because I didn't want one to fail again. So it had to happen. The demo gods were against me. I might actually quickly check the names are all correct format. Okay. This should be building appropriately unless someone at home has decided to follow along with it. I'll monitor this for a bit just to see that this builds, because the buckets will happen pretty quickly. And as you can see, the buckets are unique, so we're good to go. We can go back to our Security Hub and see what's happening now. It's been a little bit of time. So we still don't have anything measured against the CIS standards yet. It's still analysing. Can take a little bit of time. We might be able to check in later today. There can be some things on there. I will be able to demonstrate later. I have built up an environment using these labs. We're going to be doing some using some detective and corrective controls later. So I have built another environment where we can actually see this in action later. And I'm just going to go back to CloudFormation. And detective controls are deployed. So as part of the last two labs, what we have done is built basically our incident a capability to detect any security events so that we could actually employ an incident response process. We've also got some idea around how our environment is tracking against some compliance controls and policy requirements. And we've also, in our first lab, did our preventative controls as well by establishing that really good, solid account structure and our virtual private cloud for us to start building within our account, our services and solutions. So another poll, and hopefully we can get the results for this one. We might try the results of the first one and the second one after doing this one. So I really would like to know what you find the most challenging for managing your logs. I often have customers approach me saying that they find log management really difficult, and I really want to understand whether you find just the sheer volume of logs difficult to analyze. The ability to correlate logs between sources. I have a lot of customers that come to me and say this one's a challenging one, particularly if they're operating in multiple environments, not just on AWS. Defining organizational log requirements, and that's often difficult, particularly when you're working with legacy systems. Timeliness to identify and respond to suspicious events, and just generally the configuration of service and application logging. So I'll get you to make a response now, and we'll try and see if we can get the results of the first poll.
Okay, so I ended the poll and I'm broadcasting the results. The one that has the most is timeless to identify and respond to suspicious events. That's all I can give you. I'm sorry, I can't show you.
Okay, so I hear that the highest response we got is timeliness to identify and respond to suspicious events, which is perfect because we're actually going to cover some principles today and do a lab that will really help you in this area. So Corrective Controls Lab, we've basically put really great preventative controls in place. We've put some detective controls in place. Now it's time to actually be able to put in place an incident response capability. So before we go through our lab on incident response, I want to take some time to talk about some incident response principles that we talk with through customers. The first one is about establishing goals. Having an understanding of how you're going to prioritize incidents, what are the sorts of assets that are most critical to respond to, and your most important data assets, and basically stakeholder expectations for your incident response capability is really important to understand. Respond using the cloud. This doesn't just mean that it has to be necessarily for your AWS environment. You can actually also deploy an incident response capability quite easily using AWS as well. Know what you need, what you have, and what you need. So this is around having an understanding of what are the tools that you're going to need and the information sources and data sources that you will need to do a response. Do things at scale. So we're not operating on an on-prem environment necessarily with AWS when we're doing our incident response. If we're doing it for AWS, what we have is the ability to actually have auto scaling, be able to isolate specific instances, and be able to do things that scale. Use redeployment mechanisms. As you saw in a couple of the labs that we did earlier, we use CloudFormation. CloudFormation is a really powerful tool to have redeployment. So is auto scaling. Iteratively and automate everything. I apologize for the tangle of my words there. But yes, again, thinking about how you can automate the deployment of your incident response capability and how you can automate the remediation activities and the recovery activities as well. And learn and improve your process. So this is after you have an incident that you may need to manage, having an understanding of how you could do the process better, or also conducting game days which actually test your incident response capabilities and being able to actually learn and improve on those. Making sure that you update your runbooks and update any scripts to make sure that your response capability is really, really tight. Clean room. So for those that might not be aware, a clean room in a traditional sense might have been having a separated workspace whereby you would conduct forensic activity around a possible event or a possible compromise. In AWS, this is a really simple thing to set up. What I get customers to do is write a CloudFormation script that would have all the tools that are necessary to do their incident response. Make sure that access to the environment where that CloudFormation script that would be essentially the clean room is restricted to those in the security team, and be able to deploy everything really easily using APIs and being able to isolate things with APIs. We also have tagging. You saw in the CloudFormation scripts earlier, I showed tagging. You can actually tag your EC2 instances and a number of your services, making sure that you're using tagging to classify your assets and what is most critical, and being able to use those tags to effectively implement a good incident response capability. Runbooks. This one has always been a challenging one for my customers, and I think for myself as a security professional when I've been in an incident response capability. Runbooks are really, really great. They help you in a situation whereby you might be panicked or not really sure of the steps, or it might be an event that you haven't come across, to take a structured approach to how you will possibly isolate or contain the incident, how you're going to respond, who needs to be contacted, and make sure that it is a very smooth process. The key thing with Runbooks is about encouraging routine. And I understand that it's a very difficult process sometimes to think about every possible scenario, but something that I have recommended to customers when I talk about Runbooks is actually leveraging as part of the post-incident response activity to actually, if a Runbook doesn't exist, to actually document the process that was undertaken and make sure that you refine that as part of game days and ongoing testing procedures. So we're talking about the difficulty of Runbooks. I would really like to understand if everybody is actually leveraging Runbooks in your business. I've got some answers there from no, I don't see the need, to yes, we use them consistently and keep them up to date. So if you could actually post your response, it would be great.
So no, but I like to is the #1 response I'm in the poll.
So no, but I'd like to is the number one response. And that's what I actually hear from a lot of customers. So I'm not entirely surprised by it. But I am actually going to talk through why it's so important, and possibly you can use this as a really good business case to actually start an initiative to actually get some of these documented. So why is it so important? The OODA loop. For those that haven't heard about this before, OODA is actually an acronym using the words observe, orient, decide, and act. And it was actually developed by a gentleman by the name of John Boyd, who was a US Air Force fighter, a Top Gun fighter, as a lot of the materials that you read on the internet about him actually say. But he developed this loop as a result of his experience as a fighter, needing to be able to respond, take in the events that are happening around him and respond quickly. If we look at the loop, it's observation, and this is around having those mechanisms to actually be able to observe and have an understanding of what is actually, well, being able to see what's happening in your environment. Earlier, we deployed Guard Duty and Config and Security Hub, and they're really great tools for you to have an understanding of what is possibly happening in your environment to observe. The next one is Orient, and Orient is around understanding those observations. So it's applying what you're seeing and starting to formulate, have I seen this before? And what could I possibly need to act? And do I need more information? The next one is Decide. And Decide is apparently, according to John Boyd, the hardest one, because we often sometimes look at the observed and orient components too much and go into almost an analysis paralysis, as we call it, around what we need to do to decide. This is why Runbooks is really important, because it helps you to make a really structured way the right decision that needs to be done in a given set of circumstances. And then lastly, act. And this is how you would carry out the incident response, or the action that you would be taken as a result of the decision. And again, the Runbooks really cover the decide and act parts really clearly. So again, covering why Runbooks is so important. There's an algorithm on the top that Guard Duty, the ability to actually see and have some really smart machine learning threat intelligence around what might pose as a security event, some planning on how to respond to those events, and having some assistance from partners and knowledge of partners equals more sleep. I don't know about you as a security person, but I used to always wonder about the events that I didn't know about, and Guard Duty really, really helps me feel more comfortable that I've got appropriate coverage across my entire environment. We've actually found from our experience that this pattern holds regardless of product. And Guard Duty, the power of it is really, really amplified when you combine it with CloudWatch. So you can actually trigger some CloudWatch events, which would trigger a Lambda, and you can have an automated response capability. And it's also really powerful with Config. Config gives you a really great visibility of how your environment might have changed against a policy requirement and might alert to some really serious anomalous behavior. Notifications and remediations allow you, the administrator, to better meet uptime and DR goals. As I mentioned earlier, with CloudWatch, you can actually automate some of your response, which will allow you to essentially have an automated runbook happening for you. Also, with the notifications as well, you're not actually necessarily having to threat hunt as much. The threat hunting capability is reduced, which also allows you to respond quicker as well. And last, I've said this a million times today, but Runbooks and some training around them. So running some game days, practicing them, refining them after an incident is really important. So Runbooks, When you are developing Runbooks, things that you should consider is attribution. How are you going to determine what was the cause of the event? Who did it, how, and why? Do you need to get anybody else involved? Is this something that you need to notify someone, a regulator, because it's a data breach? Or do you need to also get PR involved as well? Who are the stakeholders? The forensic part, what tools will you need, and the types of data will you need? And then what procedures are going to be run? So who's going to run them, how and what using the tool? And review the ground rules you have found, build these as your guardrails. And I've just gotten a question as well. How can I and my team assess and prioritize which security issues to address? One of the really, really great things I tell my customers is having a really strong risk management and understanding of your threats and risks. So I always prioritize, when I'm developing my Runbooks, what I'll do is do a basic threat and risk assessment, have an understanding of what those threats could have on my critical resources, and applying a prioritization based on the threats that I've assessed and the criticalness of those assets. I also had another question around a game day. A game day is like a simulated incident response day or a disaster recovery day, whereby you would essentially, in a controlled manner, run or practice your incident response and disaster response capabilities to make sure that they meet the priorities and the goals that you had set earlier. So I'm just going to take you through a Runbook example. You could actually use this as a template and fill this out as you need. And again, you might have, as part of your broader security operations, standard operating procedures, some key times where you might look to actually update these Runbooks. So maybe possibly after an incident or when someone makes a major change, that you might have a requirement that you re-examine these Runbooks to make sure they're complete, accurate, and able to be run in an incident situation. So we've got at the top the problem description. So this would be around a description around the type of attack or the type of the event that might happen. The data that you need to gather and from where, the steps to troubleshoot, so to isolate and contain the event and essentially be able to determine the action to be taken, and then the urgency around the event and the steps that you need to take. I've mentioned this before, but I can't highlight this again, continuous improvement. Your Runbooks cannot be a static document. They are constantly changing as your environment is changing. Also, they change as a result of, change in organizational structure, and they also change as a result of changes in teams and team dynamics. Make sure that you constantly run testing scenarios such as the game days, which I explained before, or after an incident, re-examine your Runbooks and make sure that your incident response functions within the goals that you have set, and make improvements to make sure that any flaws or any mistakes that happened along the way are actually clarified in your Runbooks and eliminated so they won't happen in a serious security event. I actually, back in the day, I used to be a security auditor, and I'm a firm believer that detection capabilities are really, really great, but prevention is even better. The saying prevention is better than cure goes a long way, and it actually limits the amount of times that you actually have to enact your incident response. So again, making sure that you have least permissions across your environment is really, really important. So this doesn't just go for users, but it also goes for, various user profiles and services as well, making sure that you're using roles where possible to ensure that you don't have persistent access and they're limited to the privileges that are needed for the task that is going to be undertaken. Security as code, and I love security as code for so many reasons. It's, as you could see from the YAML scripts that I provided earlier, it's really easy to update the code and have them be able to be reviewed appropriately by a security auditor or a security team to make sure that they meet requirements and have controlled mechanisms to keep those scripts according to policy. It also means that we're programmatically accessing the environment and keeping people away directly from it. So essentially, we can have a number of checks against that code and make sure that people aren't just in an ad hoc manner going in and making changes. It really allows for consistency of your environment, and it means that if you wanted to deploy it across a number of accounts, that it is routinely done and consistent across your accounts. So we've talked about incident response. Now I'm going to demonstrate to you in a lab how you could do an incident response in AWS using the detective controls that we deployed earlier. For those that are doing the lab, the Corrective Controls Lab is available at the link here. But as I said, I will be taking everyone through it as well. Just to let you know, for those that have started up an account today and deployed those first three workshops, there is a possibility that you will not have any events, but I will definitely take you through today to see how you might be able to do this lab at another time and be able to navigate around. So this is the last lab, incident response with AWS console and the command line interface. Today I will be largely taking you through the command line interface as part of the lab, but I will let you know that there are instructions to do this completely in the management console if you didn't have that configured, but today we will be using the command line interface. So today, as part of this lab, we're actually going to be extensively using CloudWatch as well as part of our investigation to determine essentially what users have had some access to our environment and whether those that access, there's some concerns about it. So what I'm going to do now is actually confirm that I have some log groups for my CloudWatch that are being ingested for me to be able to actually do my incident response. So I'm just going to check that now. And this response will actually be done in the command line. I will be checking that, but we will go quickly to CloudWatch. And like I said, so I had some events that I could show you. I have actually created some things already. Oops. So as you can see, I've got some log groups set up. And they've actually been taking in some information. They've been ingesting the logs that are sitting in my S3 buckets from CloudTrail, and they've been sitting there and now available in CloudWatch. Like I said, I'm going to use the command line to actually check as well that I'm appropriately configured for that too. Oops. So as you can see here, those two groups that I showed you earlier are fully available here in a table form. I've got my detective controls group that I set up as part of the second lab and my VPC flow logs that I set up as part of the first. So now we're going to have a look at what our users have been doing in our environment. You can do this activity in the console, and we will start this activity in the console for you to have a good feel for how it operates. So here, I'm wanting to have an understanding of all the access denied attempts. This might actually demonstrate someone wanting to take a brute force, might be doing a brute force attack on our account, or possibly even trying to work out how their privileges could be used to possibly carry out some malicious behavior. So I'm just going to copy this and pop it into CloudWatch. I'm going to select my groups. I am just going to change the time frame for this. I'm just going to have a look. They've changed the console layout on me. There you go. This should run now. I'll just take another one. And the demo gods do not like me today. So, oh, there it is. I missed the F, so. We'll try this one more time, else I'll take you further through the lab. If I ran this same query, I was in the Sydney region before. Because I didn't have any events or any anomalous activity, I have actually simulated some activity, and it was supposed to turn up here, but for some reason it doesn't like me today. Okay then, I will show you here. I've actually created a couple of users, user 1, user 2, and then myself, which is the Well-Architected Lab user. I have a feeling that possibly user one is doing some anomalous activity. I've had some tip-offs from the team that they've been working late and doing some suspicious behavior. So I'm actually going to, I'll use the command line, and we'll actually have a look at what user one is actually doing. Oh. Oops. This will not work. I'm just going to that would not work because I had the wrong log group name, so I'm just going to go back in and paste this correctly.
Sarah, read the screen, the teleprompter. They say that there's a typo in your request, missing F from filter.
Yeah, so I have just realized that the people at home are telling me I'm missing the F. I did realize that, but I'll show you in the command line. We won't waste any more time, but you can actually do it in both. I'm glad that you at home or in the office have picked up on my mistake. Actually, oops. I'm just going to put the right log group in, and I've just put in the entire link. I'll just copy it as text. So this command line, this command is actually going to tell me the same thing I was looking for before. Let's start again. And I've misspelt my group again. And I'll get this command going soon. I've made a mistake again.
Can you zoom in on your console for us?
Yep.
Real quick, whenever you get
And I'm just going to zoom in on the console. And I've just made a mistake again. Sorry for those wanting to follow on again. Okay, so I got the script going eventually there. The output, I will explain what I just did in that command line, and it finally worked. So what I had done is actually posted a command line to the CLI around looking for any users that had denied activity or any sort of error when they attempted to perform an activity in the AWS environment. I've asked it to be put out in a JSON output, and this is what I've got here. To my suspicions, user one has done some really strange activity. They're coming up a lot in my logs. So I'm going to actually have a look at user one in a little bit more detail to have a better understanding of possibly what they're doing and whether or not they're doing some activity that I would consider suspicious, such as trying to create users, trying to increase their number of privileges they have to themselves, or even looking at S3 buckets. So we know that this was the first instruction for the command line, which was the access denied attempts. The next one is around the access key. So I want to have an understanding of whether or not they've done anything using a specific access key that would be would be of some concern. I will highlight to you that the scripts will only work as well, although I've had a number of issues today, joys of live demos, but you need to also make sure that you're using the right region. I am doing this activity in region US East 1, which is why I'm able to actually completely just copy and paste here from the instructions. So again, I'm going to start having a look at user one. I'm going to use my detective controls log group. Then I'm just going to copy this portion, and then I'm going to copy the access key that I saw for user one. So I've got a user access key here. I'll use this one. And I've copied in the wrong thing again. So let's redo that one. So I've got the correct log group now. And there's my mistake, almost made it again. Then we use the access key that we're looking at. And then the output to JSON. And as you can see, we can now see the times that the user 1 has used that access key. And we can kind of see what they've actually also been doing as well. So now user 1 also has an IP address with it, and I saw as well when I was scrolling through that they were actually using multiple access keys, which is a little bit strange as well. So what we'll have a look at is whether or not there is a consistent IP address that is coming for user 1. Again, my log group name, filter pattern, and we're going to use the IP address that we had for this user as well. And I did have it up here in the logs up here. There we go. It was right in front of me, looking at a computer screen. And then last of all, the output to JSON. And yes, there's a lot of activity happening from that IP address from that user. We've got some assumed roles associated with here. We're also, different keys that are being used for the user as well. I'm a little bit worried that user 1 is either doing something wrong, or someone outside of the organization might have actually gotten access to this user's account and is trying to do something that they probably shouldn't. So I've seen that there's the source IP address is consistent, some different keys, and that user 1 has had a lot of activity and had a lot of denied attempts. I have some really sensitive information in some S3 buckets, and I'm going to have a look and see what the user might have tried to do when it comes to the S3 buckets and see if they've tried to access anything that's sensitive. And yes, this user has definitely tried to do some reconnaissance activity on the S3 buckets. They've tried to list buckets a number of times, which I'm a little bit worried that they're trying to get an understanding of what information we have there and could be actually planning to do something that is a little bit more malicious than what they're doing now, which is basically a reconnaissance exercise. So something that we might decide to do while we're trying to understand what the reasons are for this user one doing all of this activity is to actually block their access. Now you can actually easily do this in the identity and access management service on the console, but today we will actually be doing it using the command line interface. So we can actually have a look at all the users that we have in our environment. So I'm just going to copy this. And as you can see, the users that I showed you before in the management console are coming up. And user one is definitely in there. We can actually, now that we know that, we've only got 3 users and we only saw from our logs that user one was problematic, I'm going to actually start denying their access. Now, for those that may not be aware, it doesn't matter what privileges I have on user one, when I implement this explicit deny policy on this user, they're going to be denied access to everything. So I'm actually going to isolate this user by denying them all access while I undertake an investigation. Start it again. So as you can see, I'm highlighting deny all. So this will remove their access to everything and trump any other policy that I have on them. And it would help if I put an A in front of it.
It said that you missed the A in AWS command.
Yeah, I am getting messages from home that I missed the policy, the start of the policy, so that's fine. I'll check that my syntax is good this time. So now I've actually blocked this user from having any access, and the way that we can actually see that in action is I am actually going to go into IAM. And I've got my user one. And you can see the permissions now, they've got to deny all against them. They were previously part of a group that has read-only access to EC2, but they're now been essentially, despite this access, they now no longer have access to anything. And you can actually, as well, if you were to investigate this user and then find out that they were actually authorized, or, you know, possibly they might have, we find out that there is an external actor using their user profile, you can then go into identity and access management and refine policies and possibly have them change their passwords, or even have them review their security policies and tighten up their access for them. So as you can see, using the command line and CloudWatch and those detective controls that we've deployed, you are actually able to start working through an incident response capability and start investigating what a user does. I think I actually demonstrated a really good reason why game days are really important, and Runbooks, having practice scenarios so that when you are in a stressful environment, being able to actually do that investigation process really quickly and ironing out those issues, such as syntax issues, which I had when I was putting in some of those scripts. Today, what I said at the very beginning is I really, really recommend that you tear down the environment, working from the last lab that we did all the way to the front. So if you go through all of the instructions, you'll actually have an opportunity, it'll have instructions on how you can remove what you have put in as part of what we've done today to avoid incurring any costs. And something I really recommend to you after today is actually go through some of those YAML scripts and go through some of the other labs. So visit our Well-Architected Labs workshops, go through them, read through the YAML scripts, have an understanding of how the scripts work, and have a feeling for how you could edit them to make them work in your environment so that you can employ security best practices yourself according to your own unique regulatory environment, or even your own organizational policies. We actually have a large list of security-focused content that you can actually extend on these concepts further and actually use these as you edit the scripts. And that's available at the link that I've also provided as well. I'm just going to highlight these are shortened links to make it easier for you to note down at home. But yes, it's we've got a number of white papers that clearly go through the services that you can use, how you can implement widely those preventative, detective, and corrective controls, how you can automate, and essentially how you can meet various regulatory requirements. So I think we're going to push through to a Q&A session now. So I have a question that's been provided to me. So I'm just going to have a look at this. So can AWS command line be run from the AWS management console? So systems manager that we have within AWS will largely allow you to run the command line interface, but I definitely recommend that you download a tool. I use Terminal because I use a Mac, but definitely there are various other tools that you can use and have it installed. But Systems Manager does allow you to have a command line interface that you can use within your AWS environment. So I have a question. Are log groups created automatically in CloudWatch, or are these things we will have to configure as well? Using the labs today, they were created automatically using that CloudFormation script. However, if you were to just use the management console, you would definitely need to do this yourself. So you would first of all need to turn CloudTrail on and establish a CloudTrail. When you go into the CloudTrail, you can edit it to create a link to CloudWatch and create a CloudWatch group for it to go into the CloudWatch console for you to do. So you will have to configure it. The CloudFormation script actually did it automatically, and I would definitely, as a call to action, recommend that anybody tries it out and has a go at actually automatically creating these groups. And I'm happy to take more questions. Okay. So I've got a question around incident response runbooks and trying to sync them with a regular incident response program policies. Runbooks are essential. What I mentioned earlier in the presentation was around having an understanding of your incident response goals. And definitely your program policies would form part of those goals, and you should make sure that when you are developing your runbooks that they're structured in a way to meet those goals. We definitely provided today an example of what a good runbook sort of structure might look like, but again, it might vary from organization to organization. The thing that I like with incident responses is to think about, when I get an event, how will my team be able to respond quickly to this event, and how will they know who to contact and what to do? So making sure that you have a clear description of what the event might look like, and have clear instructions around who your stakeholders are, and the step-by-step processes that are needed to be taken to ensure that you meet your organizational goals. So I've got another question around guard duty and other detective controls around them catching log findings and events. What is a good way to ensure these findings have high visibility and acted upon? There is, the main way I would do it is actually be setting up notifications. So you can actually set up, when we were going through the lab earlier, you could actually set up an email for how those events might be how you might have them sent to you, but you can actually go into CloudWatch and actually configure the notifications that you want to receive, and that way they can go to the person that you really want in the way that you want it. So I have seen customers have the events sent to a Slack feed. I've also had them sent to SMS, so that might be important for a customer that might, for somebody in the SOC team that might be working out of hours, and also acting on them quickly, automating the response. So using things like CloudWatch, having an understanding of the events, and actually having a look at how you might be able to automate them, and actually deploying a Lambda that is actually triggered based on a CloudWatch event, and having the actual response automated. That means that the number of manual activities that you're actually doing is you're actually reducing that number. Who is on the team is responsible for implementing the security controls and the practices we saw today? Ultimately, that will depend on team to team. I would ultimately say that this would be done in the organizations and the customers that I've dealt with somebody that's in the security operations center. You might have a security, an appropriate person within the security team that is responsible for compliance. So you might have something like a green team set up that would configure these according to policies. Also, you've got people that are doing red teaming or blue teaming, blue teaming. You would actually, for the blue teaming, they're trying to search out the people that that are doing the who might be carrying out malicious activity. And you want to make sure that the controls are configured to meet their ultimate goals that they have agreed, such as in service level agreements for the team, and making sure that the environment meets the needs for them to do their activities. I believe we're running out of time. Thank you for bearing with me. I know that we had some fun with the demos today, but I hope you all learned something today as part of this presentation. And I'm really happy that you joined and the participation that was involved, including pointing out where I had some errors with my, my command line scripts. Thank you so much for joining, and I look forward to hopefully meeting you and hearing how you're building securely on AWS in the future.